Our next example is a little bit trickier, but I still think it's a function that you've seen before. F of x equals sine of 1 over x. And we're asking, and the domain being just from 0 to 1. The problem wouldn't change if the domain went from 0 to 2 or 0 to 5 or 0 to infinity, but we're not considering 0 or negative numbers. So does the limit as x approaches 0 of this function exist? Well, I started off by graphing just the sine function, and we see how repetitive it is. Sine of n pi, every multiple of pi is 0. Sine of pi over 2 times 4n plus 1. So take, for example, this. 5 pi over 2. That's 4 times 1 plus 1 gives us the 5. 5 pi over 2. Then 9 pi over 2 would be the next case. And we have sine of pi over 2 times 4n minus 1. So like 3, if n were a 1, this would be a 3. 3 pi over 2 gives us a height of negative 1, as does 7 pi over 2. So that helps me to graph this, which is, well, let me first say that this is f of x equals sine x. And this one is f of x equals sine 1 over x. So as I mentioned down here, what does it mean for sine of n pi to be 0? Well, if we think of the function we're looking at here, this is the reciprocal function, and we're taking the sine of the reciprocal. So this would be f of what? The reciprocal of n pi, 1 over n pi. That's why this graph over here crosses 0 at every multiple of 1 over pi. Well, I should say not every multiple of 1 over pi. Every 1 over n pi. So we've got 1 over pi, 1 over 2 pi, 1 over 3 pi, 4 pi, 5 pi, and so on. So it's crossing this x-axis. It's equal to 0 an infinite number of times. Okay, I think that's enough to get started, although I'd like to, if I had more room, this is equal to f of the reciprocal of this, so it would be 2 over pi times 4n minus 1. And I'm going to use a different letter here just so my f's don't get mixed up. Sine x is not in this problem. So I graphed sine x, g of x equals sine x, just to help me graph f of x equals sine of 1 over x. And then this would be f of the reciprocal of this, which would be 2 on top, and then pi times 4n minus 1 on the bottom. So f of this number for all n is equal to 1. F of this number for all n is equal to negative 1. So we're going to prove that the limit does not exist. We're going to use proof by contradiction. I'm going to say to the contrary, suppose that the limit of sine 1 over x as x goes to 0 does exist and equals the number L, the real number L. You may have seen this before. This was kind of optional since our domain is only positive numbers between 0 and 1, but I emphasize the fact that x is approaching 0 from the positive direction, from this direction. All right, and as we noted earlier, I'm just going to remind us that observe that either L minus 1 is greater than or equal to 1, or L minus negative 1 is greater than or equal to 1. That's the same thing we talked about a little bit earlier. So the distance between L could be any real number. Either the distance between that number and 1 is greater than 1, or the distance between that number and negative 1 is greater than or equal to 1. So what I'm going to do is say, I'm going to choose an epsilon equal to 1/2. I think 1 would have worked, but I'm going to choose 1/2. For epsilon equal 1/2, there exists a delta greater than 0 such that x very close to delta, between 0 and delta, and not equal to 0, implies that sine of 1 over x minus L is less than epsilon. I numbered this statement 1. Since we're assuming that the limit exists and equals L, that means that for any epsilon I choose, there's a delta such that holds true. Because this is true for every value of epsilon, assuming that limit exists. And we'll reach a contradiction in a minute. So now, choose a natural number in little n such that, and don't get thrown away by this, it took me a minute to figure out this number exactly, n is greater than 1 over pi delta plus 1/4. And that's not the part that I care about. That means that when I solve it for delta, you could do some algebra with this statement to convince yourselves that you would get 2 over pi 4n minus 1 less than 2 over 4 plus 1 less than 8. This is what I care about. So we're choosing an n big enough so that, let me just do this. This part that I'm putting in the red shape there is equivalent to this statement. If you do algebra on this, solve it for delta, you're going to come up with this. So we're choosing n so big that it's less than delta. No matter what delta is, you can choose an n big enough so that this denominator is so big that it'll be less than delta. And this is like the best number that would work. And this we get for free, since the denominator of this is, wait, did I get those in reverse order, didn't I? These two I got in reverse order, didn't I? If the numerator is smaller, it makes the number bigger. So this should be a plus and that should be a minus, right? Is that right? Plus okay, so that being said, I might have to tweak this a little bit. It's possible. I had intended to make this equal to the smaller one. It might be that's correct, but this is the important part. We'll just double check this. It's choose little n in the natural numbers such that this is true. Okay? All right, so what that gives us, I'm going to have to write a little bit smaller here. So both this number and this number, 2 over pi 4n plus 1 and 2 over pi 4n minus 1, they're both in the interval from 0 to 1. It's from 0 to delta, let's be more specific. So that means the hypothesis of this statement is true. Because we're assuming the limit exists, we're going to reach a contradiction. So we've got that, and we also know that f of 2 over pi. I should have just named these x1 and x2. Let's see, f of this, that's the plus 1, is a positive 1. And f of the second number, pi 4n minus 1, gives us a negative 1. And all of that line implies either this thing, f of 2 over pi 4n plus 1 minus L in absolute values is greater than or equal to 1, or the other one is, or f of 2 over 4n pi times 4n minus 1 is greater than or equal to 1. And that's our contradiction. Therefore, the limit does not exist. It was much easier to convince ourselves that the statement is true just by looking at the graph. If we choose epsilon equals 1/2, it doesn't matter what delta we pick. I could say that's delta right there. Between 0 and 1, there's an infinite number of this kind of a value, where n is a natural number, and this kind of a value, where n is a natural number. So that means that it's going to have f of the first number is going to be a 1, and f of the bottom number is going to be a 2. Well, no matter where our capital L is, one of those is going to be at least 1 away from that capital L. So it turns out that if I had wanted to, I could have chosen epsilon equal to 1 instead of 1/2. Anything 1 or smaller, any positive number less than or equal to 1 would have worked.